In our last video, we saw how compounds and mixtures shape the world. But how do chemists describe these changes? Enter chemical equation, the secret code that turns burning fuel, rusting iron, and even baking cookies into a language every scientist can understand. Let's pay attention on today's objectives. By the end of this video, you'll be able to define and write chemical equations, balance equations using simple steps, decode the symbols and numbers that make chemistry universal. First things first, let's understand what a chemical equation is. A chemical equation is a way to show a chemical reaction using chemical symbols and formulas instead of words. It tells you what to start with, which is called a reactant, what to end with, which is called the products, and how the change happens, which is shown by the arrow. So reactants are the starting substances that undergo a chemical change. Products are the substances formed as a result of that change. So in short, reactants make products. For example, hydrogen and oxygen produce water. Or in chemistry's secret code, 2H2 plus O2 produce H2O. Now, let's learn how to write a chemical equation step by step. Step 1. Identify reactants and products. Calcium carbonate plus hydrochloric acid makes calcium chloride, water, and carbon dioxide. Step 2. Write the formulas. Solid calcium carbonate plus hydrochloric acid makes calcium chloride plus water plus carbon dioxide. Step 3. Addition of state symbols. Now let's add something extra to our chemical equations, state symbols. Why? Because state symbols don't just tell us what substances are reacting, they tell us how they exist during the reaction. So S for solid, AQ for aqueous, L for liquid, and G for gas. These symbols are always written in brackets right after the chemical formula. Let's quickly take a look on aqueous and its meaning. When we say a substance is aqueous, we mean it's dissolved in water. It's not just sitting there. The water has broken it down so the particles spread out evenly, forming a solution. Let's use sugar, for example. When you stir sugar into water, it dissolves. It spreads out so much you can't see the crystals anymore. Now it's a sugar solution, and in chemistry we call that aqueous sugar, written as sugar AQ. Before we go any further, we need to talk about one of the most important parts of writing chemical equations, balancing them. Our golden rule in chemistry is the law of conservation of mass. Yes, atoms aren't created or destroyed, so the number of each kind of atom must match on both sides of a chemical equation. Okay, here is a clear, step-by-step way to show that idea and to balance the example. Hydrogen plus oxygen to make water. Step 1. Let's count the atoms on both sides. On the left side, we have 2 hydrogen and 2 oxygen. And on the right side, we have 2 hydrogen and 1 oxygen from water. But the problem is the oxygen doesn't match. We have 2 on the left and 1 on the right. So let's move on to step 2. Balance oxygen with a coefficient. If we place a 2 in front of H2O, we'll double the water molecules. Now let's recalculate. 2 hydrogen times 2 will give us 4, and 2 oxygen times 1 will give us 2. Oxygen is balanced, but hydrogen is not, because we have 2 hydrogen on the left and 4 hydrogen on the right. Step 3. Now we are going to balance hydrogen. To fix hydrogen, put a 2 in front of H2. Now let's check again. On the left side, 2 hydrogen times 2 will give us 4, and 2 oxygen times 1 will give us 2. On the right side, 2 hydrogen times 2 will give us 4, and 2 oxygen times 1 will give us 2. Both sides match perfectly. So our final answer is 2 molecules of hydrogen gas react with 1 molecule of oxygen gas to produce 2 molecules of liquid water. Let's try this together. We'll start with photosynthesis. The unbalanced idea looks like this. Carbon dioxide plus water with sunlight makes glucose plus oxygen. Glucose has 6 carbons. We need 6 CO2. Glucose has 12 hydrogens. We need 6 H2O. Now check oxygen. This gives us 6 O2. When balanced, it becomes 6 carbon dioxide molecules plus 6 water molecules with sunlight makes 1 glucose molecule plus 6 oxygen molecules. Now, let's practice with a different one. Nitrogen gas plus hydrogen gas makes ammonia. Now pause the video and try. Well done. When balanced, it becomes 1 nitrogen gas molecule plus 3 hydrogen gas molecules makes 2 ammonia molecules. But why do we balance equations? Balancing equations shows that mass is conserved. What you start with is exactly what you end up with, just rearranged. This is the law of conservation of mass. It's like making a sandwich. You can't use more bread than you have, and you can't make extra cheese appear out of nowhere. Let's play a game. I'll show you an unbalanced equation. You have 30 seconds to balance it. Are you ready? Here's one. Iron plus oxygen gas makes iron 3 oxide. Great job. When balanced, it becomes 4 atoms of solid iron react with 3 molecules of oxygen gas to produce 2 units of solid iron 3 oxide. Now, let's take a look at the key takeaways. Chemical equations are the universal language of chemistry. Reactants go on the left, products on the right. Balance equations by adjusting coefficients, not subscripts. Next time you see fireworks, bake a cake, or watch a car engine run, remember, there's a chemical equation at work, and you can write it. Stay curious and keep decoding the language of chemistry. Hello, learners. Feel free to drop by and visit our website for more free resources, worksheets, and tuitions. Visit us at www.anselhillacademy.co.uk today to get started, and subscribe for more updates, tips, and learning materials.